Our next speaker is going to be Dr. Keita Okuda. He's a PhD for Technical Service Team Lead at Amano Enzyme USA with 12 years of experience in R&D. He received his PhD in Bioagricultural Sciences from Nagoya University in 2013. His professional interests focus on how to add value to food sector by enzymes, and his current projects include technical support for his customers. The description of his presentation will be talking about enzymatic modification, has a lot of potential as a green technology. Protein glutaminase, Amano 500, PG 500 especially improves the solubility of a plant proteins by deamidating, I'm very sorry, that's a tough word for me, the amino group of glutamine residues in protein. PG 500 opens a whole new array of product options in plant-based applications. So with that, and his presentation again is improvement of plant protein functionality by protein glutaminase. With that, Dr. Okuda, take it away.
Thanks for kind introduction, Bruce. And Amano would like to thank you for tuning in for this presentation. My presentation title is Improvement of Plant Protein Functionality by Protein Glutaminase. Before I get started, let me introduce Amano Enzyme briefly. First, we are a family-owned Japanese company with 120 years history. And we have developed a lot of unique specialty enzymes, like protein glutaminase that I will talk about today. Our uniqueness derives from three distinctive synergies. Let me break down. The first, from application side, we are supplying enzymes to the food and medical sectors, which help us develop innovative application to both markets. And second, from production side, we produce enzymes by Kouji fermentation and liquid fermentation, which enable the production of a wide range of unique enzymes. Finally, the other synergy we have is that most of our enzymes are non-GMO, which is classical biotechnology. At the same time, we also focus on modern cutting-edge biotechnology, like protein engineering and genome editing, so that we can differentiate and create a unique value proposition. Also, by taking advantage of these, we can offer tailor-made enzymes for customers. As I mentioned earlier, today's presentation is about protein glutaminase Amano 500, or PG 500 for short. I'd like to start with general information. Then I'll cover application examples later on. Here are some benefits of PG, like improvement of solubility, mouthfeel, stability, and foaming. So you will see more detail later on. The first introduction, PG 500 comes from a non-GM microorganism. Specific name is Crystobacterium proteolyticum through a unique fermentation process. It's the only enzyme on the market that will deaminate the side chain of glutamine in whole proteins and convert to glutamate. Other glutaminases on the market require monopeptide glutamines to deamidate. Then finally, PG 500 is effective on a wide range of protein sources, which I'll touch later. On the right, you can see the crystal structure of PG. It was published back in 2011. The red colored area is the substrate binding site. This diagram displays what PG500 tries to accomplish. Normally, glutamine has no charge in neutral condition, causing protein to not be soluble. Then, as I mentioned earlier, PG500 converts glutamine to glutamate without peptide cleavage. So, glutamate does have a charge. As a result, the isoelectric point shifts to slightly lower pH, and this deamidation likely opens up protein structure and increases the solubility of the protein. And moving on to the general characteristics of PG500. Here you'll see 4 different charts. The upper left is about the optimum pH for incubation. As you can see, PG500 prefers acidic to semi-alkaline condition. The upper right is about pH stability. PG is pretty stable over a wide range of pHs. Then the bottom left is about the optimum temperature for incubation. PG works best between 50 and 60 degrees Celsius. And finally, the bottom right is about the thermostability. PG is stable up to 60 Celsius and can easily be deactivated at the temperatures over 70 Celsius. Now, overall, the characteristics of PG seems to fit into the food industry process. This table shows the substrate specificity of PG. You can see casein, lactoglobulin, and collagen. These kinds of animal source protein. You can also see gluten, and soy protein, and dairy, these kinds of plant-based protein. So I would say PG works well with a variety of protein sources. Then from this slide, I'd like to talk more about application examples using PG. Obviously, the plant-based trend comes with challenges such as poor solubility of the plant proteins, gritty mouthfeel of the plant proteins, and poor functionality. The Amano would like to introduce PG500 to offer solutions such as protein content improvement, mouthfeel improvement, and handling improvement. So then the first example that I want to talk about is protein solubility. Here, we tested PG500 with a variety of protein sources, such as chickpea, soy, rice, and almond. As you can see from this chart, almond protein solubility is improved the most with PG500 treatment. However, even pea protein, which is well known for its poor solubility, has its solubility increased by 50%. So this data indicates that more protein can be introduced as soluble state by PG treatment. Okay, so moving on to the next. This flowchart shows how to produce protein isolate from flour through chemical separation. Normally, it starts with alkaline treatment to separate fiber and starch, followed by precipitating proteins with acid. The idea is to apply PG500 at the beginning stage of the process so that PG500 allows more protein to be soluble. So, it shouldn't matter what extraction technique you use, as long as PG500 can react with the initial material. This chart shows PG effect on 3 different plant protein sources. As you can see, the more protein is obtained as PG dose increase. Also, another thing I'd like to mention here is that PG treated protein powder has unique properties in terms of viscosity, solubility, and mouthfeel. As you can see, at 30% concentration, PG treated pea protein is less viscous than untreated. And in terms of protein solubility, PG treated pea protein is a lot more soluble than untreated, as shown in the previous slide. Finally, about mouthfeel, our sensory evaluation confirmed that PG-treated pea protein solution has smoother mouthfeel than untreated. So I'll cover more detail about mouthfeel in the next slide. We have conducted some tribological tests to analyze the mouthfeel of plant-based milks. In this test, the result showed that PG-treated soy milk, which is green line, has a lower coefficient of friction than untreated soy milk, which is gray line, meaning it will feel smoother when drunk by consumers. Here we only show the data about soy milk, but we also have a similar data for other plant milks, like rice milk. Another big challenge for plant-based milk is that they curdle when added to coffee or some teas. Questions arise as to why certain milks curdle and others do not. The reason is that the isoelectric point of the proteins within the milk, PG500 modified the isoelectric point of proteins to lower pHs. This change prevents the curdling from occurring when added to the acidic coffee or tea. We used almond milk for this study. The isoelectric point of proteins in almond milk is around 5.5, and after treatment, PG treatment, it shifts to around 5.0. This change allows for almond milk to be stable in coffee. So we prepared 2 almond milks. One is treated with PG, the other is not, which is control. Then these 2 almond milks were added to coffee. As you can see from the right-hand side, the control sample almost immediately curdled after being added and swirled, while the treated sample remains stable throughout the test, which is a big advantage as producers can achieve this with clean label. I mean, they don't need to add buffering salt in order to maintain neutral pH, even after adding to coffee. PG also adds value to protein drinks by allowing producers to increase the range of flavor options they sell. With PG500, they are no longer limited to the flavors that require neutral pH, such as vanilla and chocolate. With PG500, they can introduce flavors that are better served at lower pHs, such as strawberry, cherry, and other fruit flavors that are desired by many consumers without the fear of sedimentation or curdling. Here we produce two strawberry flavored pea protein drinks, having 5% protein concentration at pH 4.5. The control sample, which only have gums as stabilizer has settled and created this unattractive layer of sediment. On the other hand, the treated sample remains homogeneous. We assume PG500 deamination of glutamine allows protein to better contribute to stabilizing the network of interaction and work synergistically with gum system to create the homogeneous protein beverages at a wide range of pHs. This slide is about the shelf-life study using the samples from this trial. Same as the previous slide, the only difference between control samples and treated samples is the addition of PG500. The samples were stored at 4 degrees Celsius. As you can see, the treated samples are far more stable than the controls. After 2 weeks and 5 months, the stability offered by the use of PG500 and gums extend visual shelf life of protein beverages more than just gum system alone. Finally, in terms of foaming, PG500 offers better foaming and foam stability. As you can see, soy milk treated with PG500 has 50% better foamability and 50% better foam stability than the control. Then, by combining these multiple benefit PG brings, you can produce plant milks having better froth without curdling in coffee. This is the last slide to conclude my presentation. It's been my pleasure introducing PG500. PG500 is a unique enzyme that deamidates glutamine in protein and having a wide range of substrate specificity, and PG500 with the opportunities it brings to protein solubility, mouthfeel, foaming, and stability. Okay, that's all my presentation. Thanks for your time.
Hi, Keita. Great presentation. Very interesting. I mean, you just kept coming with more and more benefits to this thing as you were going along. One of the questions that I had for you is how has this been adopted to the field? I don't know how long this has been in the market. Do you have a lot of customers using it today, and how's your business doing with this product?
Yes, I mean, we are having pretty good business with a lot of customers, and obviously the PG fits in the current trend, which is the plant-based trend. Mm-hmm. So, I mean, yeah, it's growing.
How stable is the enzyme? Meaning when someone purchases it, how long do they have before they have to use it, or is there any issues in that area?
No. In terms of stability, we guarantee 18 months to 24 months.
Okay.
For the activity, yes.
Okay, good. There's a question that came in. It says, we can anticipate a wide range of possible applications for enzymes in plant protein to alter proteins to have better functionality. How do you design new enzymes to meet new customer requests?
Oh, yeah, it's a very good question. I mean, yeah, it depends on the customers how they can achieve in the process. Mm-hmm. We have a lot of enzyme. I mean, we have a lot of strains, microbial strains. Then we can screen out which strain can fit the customer's desire.
Yeah, I saw on your website you guys you're probably the biggest in Japan in terms of enzyme production and applications. So I'm sure you have a lot of research and stuff that can help in those areas. And then I guess from from a cost side, I mean, initially when you started, I thought there was a few benefits, but as you kept going, I thought, well, someone's going to pay for this. So do you see any issue in the field from a cost side from people saying, hey, that's too expensive, or are they just saying, look, all the benefits, it's well worth it?
Yeah, it's more likely more worth it. It's kind of always trade-off.
Mm-hmm.
So definitely PG can add more values to the customer's product.
Mm-hmm.
In the meantime, the customer have to think about the cost wise. So it's kind of, trade-off.
Sure, sure. All right, excellent. That's all the questions that I have, Keita. It was, again, a great presentation, and I'm sure our audience got a lot out of that. So thank you again for the presentation.
Yep. Thanks, Bruce.